Hi, I'm Paul. We are doing Leetcode must know interview questions. Today's challenge. Reverse bits. This is rated as easy, but if you are not if you're not especially conversant with bitwise operators and ors, I'm not sure this is. I mean, let's put it at the upper echelon of easy. I mean, so here's the challenge. Simple. Reverse bits of a given 32 bits unsigned integer. Note, all these notes have something to do with Java, which is the language that I'm using here. Note that in some languages, such as Java, there is no unsigned integer type. In this case, the input and output will be given as signed integer type. Should not affect your implementation. In Java, the compiler represents signed integers using 2's complement. That really shouldn't be of any interest. Okay, so our input is an integer, n. It is, I mean, it's a decimal integer, but it's intended to be interpreted as binary, so we would get something in like this. Now, we wouldn't get something in exactly like that because, of the leading zeros. There wouldn't be leading zeros. That is just for demonstration purposes to indicate that if you reversed it, you would get something like that. And then return the decimal equivalent of that, which in this case is 964 million something. Okay. So let's think about how we could do that. Okay, I think it's too difficult to, try to do a 32-bit walkthrough of this. So let's do an 8-bit walkthrough of this. And let's do n. There are 3 variables, I think, that are of interest to us here. One is n. Let's make n 5. So that would be 1, 0, 1. Now, according to the way they're doing it in the examples here, it would be, you would have 5 more zeros in front of that, but really you wouldn't. It's n equals 1, 0, 1, that's 5. Now, we're going to have some kind of result, and it probably is easier to see this in terms of an 8-bit result. So we're going to initialize it to 0, right? And then we have I, which is going to be our loop counter. All right, I will start out as 0. Okay? The first thing that we want to do is to get the least significant bit of n. And we can do that using n and 1. Okay? So if you and n with 1, if you and anything with 1, what you're going to get is the least significant bit. In this case, that would be 1. Okay? Shift this bit to its reversed position. Okay, so to do this, we shift it by, in this case, 7. In the case of a 32-bit integer, it would be 31. But in this case, it's going to be 7 minus I. So if we shift this 7 digits to the left, we're going to have this with 7 zeros. And I shouldn't have put this down here. 1, 2, 3, 4, 5, 6, 7. And then we are going to OR that with, yeah, I guess putting it down there is okay. And then we're going to OR that with the result. And the result becomes, yeah, I don't want to do that. If you OR this with result, it's going to be 1, 0, 0, 0, 0, 0, 0, 0. All right. We are now going to right shift n by 1. So that puts the next digit in play. Right shift it by 1. So now we have this 1 and 0. All right. We're going to do the same thing again. We're going to AND n with 1. And if we do that, let me erase this. If we do that, we're going to get 0. We are going to, and actually this is the second time through the loop, so I is now 1. We're going to left shift that by 7 minus 1, which is 6. 1, 2, 3, 4, 5, 6, and then OR that with the result. Well, these 7 zeros match up with these 7 zeros, and so the result doesn't change at all. Okay? Right shift n by 1 again, and we'll get this 1. Okay? We're going to AND that with 1, and we're going to get 1. All right, this is the third time through the loop, so I is now 2. All right, 7 minus 2 is 5. Left shift this by 5. 1, 2, 3, 4, 5. OR it with the result. And we'll get 1, 0, 1, and then 5 more zeros. 2, 3, 4, 5. If we right shift this again, it zeros all the way, so nothing is going to change after this point. But we have reversed the input, which again, for example purposes, would be 0, 0, 0, 0, 0, 1, 0, 1. And now we flipped it as 1, 0, 1, followed by 5 zeros. All right, so let's try and implement that. All right, so the first thing is we need something to return. So we were calling it res, result, initially 0. All right, so now we're going to loop over the 32 bits of the input. So for int I equals 0, I less than 32, and n is not equal to 0, because in a case like this, or the example that we did the walkthrough, a case like this, you're not going to have, it says you're going to have a 32-bit integer, right? Is that what it says? The input must be a binary string of length 32, but it's not a string, it's an int. So there's no leading zeros, okay? And so it's possible that we are going to run out of digits before we get to 32. So we got to make sure that that n is not equal to 0. I plus plus. All right. So the first thing is we AND the number with 1. N and 1. And that gives us the first digit. It isolates the least significant bit, if you want to Think of it that way, the least significant digit. All right. We want to shift that by, in the example we did 7 minus I, and in the real one we'll do 31 minus I. We're going to shift it, and then I might need parentheses around all these. It's not going to hurt. And then result, we will OR it with that number, which is what we did in the example. All right, the next step is N, and we're going to shift equal, I'm not sure if that's the right symbol for that. 1. We're going to shift it to the right by 1 to expose the next digit. Okay? And then, once we get through all that, we will go ahead and return the result. All right, so we can try and run this. I think the only thing that might go wrong is that this symbol is incorrect, but if it is, I know how to fix it. Oh, okay, no, that's accepted on the base cases. And then submit. Okay. All right, so that's good. Good time. Yeah, so reverse bits. How do we? Okay, so again, to recap, reversing bits. It's kind of an unusual way to do it, where they give you the bits as an int of zeros and ones. But in any case, just isolate the least significant digit, and then shift it left into its correct position. And the way you do that is, if you've got a 32-bit number, 31 minus I, shift it left, and then OR it with the result, and that'll put all the ones in the correct places. So that's it. Hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.